presentation is on modeling robo navigation to assist differently abled persons. Now we use the word differently abled persons rather than disabled persons. And the presenters are Mr. Rajaguru and Mr. Malpana, who will be coming forward. One is a miss, is it? Mr. Rajaguru, okay, and Miss Malpana, and Mr. Rajaguru and Mr. Malpana, and Mr. Rajaguru is the undergraduate of the Kotalawala Defence University, Ratmalana. It's not MS, not this. It's MSc, no? She is now. She can't be. She.
No, sir, I'm Malpana.
That's right. Here. Mr. Malpana.
Yes, sir.
Mr. Malpana is undergraduate of the General Sir John Kotalawala Defence University, Ratmalana. He is following a bachelor degree in computer science. He is now in the second year. He has learned and currently trying to master languages such as Java, C, and HTML. His research interests include AI and web development. Make the presentation.
Yes, thanks. Session Chair, Professor A.K. Y.W. Pereira, ladies and gentlemen, a very good evening to all of you. As we all know, in the modern day, hospitals and healthcare system has a high demand. To support this high demand, we present on modeling robot navigation to assist differently abled persons by LDSP Veerasinghe, HSS Mallasekara, RMJCK Rajaguru, DS Tannagidara, K Malpana, DMR Kulasekara, Professor A.S. Karunanand. Now we will move on to our content. First we start with the introduction, then moves to problem definition, literature review, approach, system overview, experimental results, and finally conclusion and future work. Introduction. As we all know, to take treatments from a hospital in today's world, we have to go through several procedures, and those procedures includes like staying in a queue, going to several places before taking the treatment, etc. And this can be really conflictive and could be really difficult for some people. And conflicts, as in when you go to take treatment, a person who needs urgent treatment go to take treatment, the normal procedure of a hospital has to be changed and conflicts occur. And when difficulties mean, especially for pregnant ladies and differently able people. Problem definition. The above mentioned, previously I mentioned, the facts are really harmful for a country's development in every aspect, because it wastes its population's time, money and all. Therefore, they have been searching for a solution throughout many years, but considering the facts, budget, cost of equipment, availability of skilled staff, not only for hospitals but for airports, lobbies, etc. But the rising question is how. We came up with a solution. Now our solution is a line following robot which helps the hospitals, to keep going a general procedure to take treatments and could handle exceptional situations. And now this image shows a typical modern day hospital which runs a hectic schedule, and it is really troublesome for all the parties involved. Now the next image shows how many places a person has to go before taking the treatments. And finally, our main concern, the differently able people, how much difficulties they face when taking treatments. And we did some literature review on our solution regarding our work done by other people. The first one was a robot built by Mania Abdul Ghan, and the specialty in this robot was inclination, and it could detect any kind of inclination on its way. And Pagdaman has designed a small line following robot using IR sensors. It could follow a path which is predefined using IR sensors. And Roman Rosario further extended these concepts and made a robot that is intelligent. And Clock's robot is mainly for entertainment purpose, and it could carry up to in shopping malls, and it could carry up to 400 kilograms of load. And now we will see the special features in our robot. It could identify every junction in the path, mainly the 90-degree path which we have implemented in our system. And it could avoid the obstacles in the path. As in when a patient is blocking the path, it won't collide with the patient, it would stop and wait till the patient moves. And it could serve any patient who is within the 1500 meters range. And the robot, especially the robot, can maintain a queue according to the priority. The queue means it keeps the queue according to the time the patient arrived, and but it gives priority to a patient who needs urgent treatments. Next, we will show you some videos which illustrates the basic concept behind our robot.
First, the patient comes to the hospital and takes a seat. Then the sensor emits a digital signal to the transmitter, and the transmitter transmits the signal to robot. After receiving the signal, the robot will move along the line but won't take a turn from first two turning points. First two digits, when considering from left to right of the signal, are 0, but the robot will turn in the third cross path because third digit is now 1 in the signal. This robot will use the same method for rest of the digits in the signal to identify the patient. This is a simulation of our robot done in Proteus. These blue color components are the sensors we are using. When they receive the appropriate signal, they turn red. The sensor in front is used to detect obstacles on the path. The rest of the sensors are used to detect the path. This is the PIC we are using, 16F8778. The motor controller L298 and the two motors that are connected to the wheels. Now we are going to simulate our previous incident where the robot received a signal 10100. At this moment, only the middle sensor detects the white line and both the motors rotate and wheels are moving forward. This situation where robot detects an obstacle on